0.
0, 0, 0, 0, 1, 1, 1, 0, 1, 0.
0, 0, 0, 1, 1, 1, 1, 0, 0.
What are you guys talking about?
0, 0, 1, 1, 1, 0.
What? What's your computer, kid?
Guys, don't leave me out of this.
If you're ready to use up that RAM, let's get to it.
Binary or binary notation is a type of base 2 notation with two terms, 0 or 1.
You see, Adam, everything in your computer, in its basis form, is made up of binary.
I see. So values that we can comprehend, like the number 6, use binary to be comprehended by the computer.
That's right, Adam. You could represent me in any way you'd like.
But how exactly do numbers get converted?
I'm glad you asked. Before we can truly understand how binary functions, we have to understand what a bit is. A bit is a unit which can either represent a 0 or a 1. The more bits you have, the more values you can represent. And if you have 8 bits, you can call that a byte.
That's totally rad.
Bits are read from right to left. So the first bit can represent 2 to the power of 0 values, the second bit can represent 2 to the power of 1, and the third 2 to the power of 2, and so on. Basically, each bit can represent twice as many values as the bit to the right of it.
Hey, I think I'm starting to get this. So 3 bits can represent any value up to 7, and 4 bits can represent values up to 15.
Yes, Adam, that's how it works.
Now then, let's move on to binary representations.
Splendid. Binary can represent many different things aside from numbers. It can even translate to letters, videos, or an image.
Represent this.
Wow!
I am binary Adam. Listen up, Choco Nuts. I am going to explain how other types of data, like videos, text, and images, can be represented in binary.
That's our job.
Not anymore. Each punctuation mark, letter, and special character on the ASCII table is assigned a specific binary value. For example, an uppercase A is 1, 0, 0, 0, 0, 0, 1.
Quick, Anji, get that binary in here.
While that's happening, let me explain how images can be represented in binary. Each image is made up of tiny units called pixels, and each pixel is assigned an RGB value that determines its color. RGB stands for red, green, blue, and each letter can be assigned a binary value up to 255. The higher the value, the more intense that color. For example, if I have a value of 255 for red, and 0 for blue, and 0 for green, I'll get the color red.
I found it.
No! Well, anyway.
Phew! Now that that guy's gone, let's talk about audio. Audio can also be represented in binary by sampling the analog audio signal and converting it into binary. Pretty much, the higher the sample rate, the higher the quality of the audio will be converted back into binary. It's storing a certain part of the audio signal into binary and then converting that back.
And with both audio and images, you can make a video. Videos are a series of images called frames played after one another. The FPS, frames per second, determines how many images are played in a certain time interval. The audio file for the video is played in tandem with the images, then a video is born.
10011?
10001111.
No!
Alrighty then, let's get into it. 5 bits can represent numbers up to 31, so we're going to need 6 bits to represent this number. We'll subtract the highest place value and put a 1 for that place. So, starting with 32. Can 32 go into 43? Yes. So put a 1 in that place. 43 minus 32 is 11. Can 16 go into 11? No. So we'll put a 0 in the second place. Can 8 go into 11? Yes, it can. Can 4? No. Can 2 and 1 go into 3? Yes. So we'll put a 1 in the last 2 places. Our final answer is 101011.
Hello, computer science friends. Today I'll be answering this here demonstration question. So BASIC presents 63 values of 6 bits. And that's because in 6 bits you can represent values 1, 2, 4, 8, 16, and 32. When you add all those up, it would be 63. And in order to double the amount of values, you need 1 extra bit.